I'm Brian Sullivan, Chairman of the Property Insurance Report online conference and editor of Property Insurance Report. When the modern quadcopter drone first appeared on the scene less than a decade ago, the benefits to insurance were immediately clear. We knew that if we could get up in the air, we could not climb on a roof, we could fly around and see things we could never get in resolution photos that no satellite could ever produce. The biggest maker of those drones, DJI, has graced our stage. We've even flown one of their drones around our lunches and taken some pictures. And many companies work to include this kind of technology into their process. EagleView is one. Bry, which manufactures a lot of its own drone, was another. Loveland Innovations has also worked very hard with these beginning tools as they evolved. And the goal quickly became the need for autonomous flight. Flying these things by yourself is very tricky, as I've learned the hard way, crashing into a number of trees. But if you can get the drone to fly itself, avoid obstacles, it makes a huge difference. And we've made some steps in that direction, and we already have some tools with autonomous flight. Today, we're going to take a look at the next step in autonomous flight technology. A company called Skydio has brought a brand new product to market, which shows some of the best tools that I've seen in autonomous flight. This entire collection of manufacturers of flying machines and the software that make them go is a remarkable achievement for the industry. And it's going to be so exciting to see how these things roll out into the marketplace. Enjoy.
Hey, my name's Bry. I'm co-founder and CEO of Skydio, and I'm really excited today to share with you the work that we're doing with EagleView for autonomous roof inspection. So I'm going to start with a little bit of background on the drone industry. So as I'm sure many of you have seen, drones came onto the scene 2013, 2014 kind of time frame, and there's all these amazing use cases. The concepts are awesome. You can have drones take amazing video, you can have them do inspection, mapping, monitoring, security, you can put them into dangerous situations, keep people out of harm's way, you can also do physical goods delivery. So the potential with drones is enormous, and there's been a lot of hype and a lot of excitement about what drones can do across all these different kind of industries and applications. But the actual delivery has fallen pretty far short of that. And predominantly, we're still living in this kind of manually flown drone world where if you have an expert pilot, or in some cases, multiple expert pilots, you have a team of experts that know what they're doing flying these devices, you can start to do some useful stuff. And we're seeing this happening today. You see consumers taking cool videos, and the companies that are willing to put up with all the pain and friction associated with manual drones are starting to deliver real value. And some of these use cases are beginning to come to life. But it comes with a bunch of limitations. And if you look at what's happening out there, by far the biggest cost and the biggest friction point for any kind of drone operation is the operator, the pilot. And it's not just, the point is, it's not that you need to have people out there doing this, it's all the training that goes into it, the liability associated with it, the issues that can come up. These things crash all the time. So there's a bunch of pain and friction points associated with this. And the belief behind Skydio is that there's a fundamentally better way of doing things. And we've seen these kinds of evolutionary cycles in other industries. And we really feel like the future of the industry, the future of drones, is AI, autonomy, and automation. It's a very simple concept, makes a lot of sense, but it's extremely challenging to deliver on. So the manually flown drone world that we're living in today makes a lot of sense if you look at the heritage of these devices. And they basically grew out of RC toys. People have been flying RC helicopters for decades. And the drone today is kind of the natural evolution of those RC toys. So, the sensors that go into phones made them smart enough that they can do basic position hold. You put a camera on there, it turns out to be a really useful device. And that's essentially what the typical manually flown quadcopter of today comes from. At Skydio, we're trying to do something fundamentally different. We're coming at it really thinking about this thing like a flying computer. It's software driven, it's software defined, it's got a lot of sensing on board, and it's fully autonomous. And we think that's the future of the industry. So this happens to be stuff that we know a lot about and love working on. So my co-founders and I met when we were grad students at MIT. And our lab was one of the first in the world to put full-fledged computers and sensors on flying devices and get them to do smart stuff. So this is a video from my master's project. This is a project that we started in 2007. This video was from 2012. This is an airplane flying itself around in a parking garage fully autonomously. So it's got a map of the world. It's flying in a stable, predictable way, avoiding obstacles. And this was really groundbreaking research. Our lab was on the forefront of this field for a number of years. And this was before drones were really seen as an emerging technology category. So we were just working on this stuff at the time because it seemed really interesting and challenging. But it's really the foundation upon which we started Skydio. And the motivation for starting the company was looking out, seeing the enormous potential of what drones could do, and believing that autonomy was going to be the key missing ingredient. So very simply, our mission is to make the world more productive, safer, more creative with autonomous flight, and that's what we're doing. So throughout the history of the company, we've kind of interwoven hardware and software development, and both of those ingredients are really key to get to the kinds of capabilities that make these devices trusted. So we kind of started with the research foundation from MIT. We started iterating on this autonomy system, which you can really think of as analogous in the same software system that would go into a self-driving car. Our first product, Skydio R1, shipped in 2018, which we kind of think of as the Tesla Roadster of autonomous drones. It's a first generation product. It proved what's possible, but it wasn't really scalable. But it laid the foundation for what we're doing now with the second generation of our autonomy system, which is heavily leveraging deep learning throughout, and Skydio 2, which launched at the end of 2019 for consumers, which we think of as like the Model 3 for autonomous flight. So to give you a flavor of what these products are all about, I'll show you some videos. So this is the consumer launch video. How is this possible? So I want to kind of take you under the hood and show some of the technology that enables us to have this kind of capability. So I've got a Skydio 2 here, and the starting point for us, it starts with the hardware, and this thing is designed for fully autonomous flight from the ground up. So it has 6 4K cameras. It's got 3 on top, 3 on bottom. These are fisheye cameras, so they have a 200-degree field of view, and they see everything around the drone in every direction at high resolution. In fact, every point in space around the drone can be seen by at least 2 of these cameras, and oftentimes 3. So there's a really powerful sensing foundation there, and then we're carrying an NVIDIA TX2, which is a really powerful CPU, GPU combination. It's essentially a supercomputer in this size and weight class. It's the most advanced computer you can fit onto something this size, which has incredibly advanced compute capabilities. So we've given ourselves kind of flying camera, flying computer capability from a hardware standpoint, but of course the real magic is in the software. And you can think of the autonomy system here as analogous to what you'd find in a self-driving car. And the simple way to think about it is, similar to how people behave with intelligence. So it sees the world, it understands what it sees, it then uses that understanding to predict into the future, and then it uses those predictions to come up with useful action. And there's a bunch of components that need to work for the whole system to behave the way that it does. On each of these components, we've really broken new ground and have state-of-the-art performance, but the real magic is in having them all work together. So I'll just quickly walk through a couple of examples here. So this is how the drone sees the world. So this is looking out through one of those navigation cameras. And then those little green dots that you see are unique features that it's identified in the environment. So it's tracking those features over time. And this becomes the basis for the drone knowing where it is and how it's moving in the world. So most manual drones are heavily reliant on GPS, which works okay in wide open spaces, but tends to run into trouble when you get in close and try to do these inspection tasks. Whereas Skydio technology is based on vision. So because of these cameras and because of this visual navigation system, it always has an ultra precise, highly robust, accurate of where it is and how it's moving. It can use GPS if it's available, but it's not dependent on it. So this gives us a really powerful foundation. The next piece of the puzzle is understanding the 3D structure and sometimes even the semantic context of the world around you. So there's traditional computer vision methods that people have been using for stereo vision for many years, But we started a pretty unique line of research on using end-to-end deep learning to estimate depth based on multiple cameras. So this has been going for many years at Skydio, and it's something that we've got in production now in Skydio 2. So on the left you see the camera input image, and then on the right you see the output of the deep neural network. And the really powerful thing here is that neural network can start to use context the same way that a person would. So it actually knows if it's looking at a tree branch, or it knows if it's looking at a power line, say. So it can do the same thing that a person would do, or if it sees part of the power line, it can assume some extent there because it has the context. And similarly, if it's looking at a big textureless surface, like a big white wall, it can start to fill in the same way that a person would. So it's an incredibly powerful system based on machine learning. And the next step in the pipeline is turning that into a dense, full 3D representation of the world, which is what you're seeing here. So this is the persistent local map that the drone builds up from the world around it that it's using to navigate and avoid obstacles. And the final piece of the puzzle is taking that map and predicting into the future based on what the mission it's trying to accomplish to avoid obstacles. So this kind of snake that you see extending out in front of the vehicle, the white and blue snake, that's its prediction of where it's going. It's taking into account the full environment, the dynamic maneuvering capabilities that it knows that it has, and it's using all of that to many times per second replan and make sure that it's staying safe and avoiding obstacles. So there's a lot of hard technology that comes together to make the system possible. And of course, all of this that I've shown so far is in kind of idealized, easy scenarios. The real challenge is dealing with all the stuff that you see out there in the real world. So this is just kind of a basic sampling of very thin structures, sun glare, motion blur, reflective surfaces, big textureless surfaces, water droplets on the lenses. And this is where we've invested the most time and effort to get the system to behave in a trustworthy way and be fully autonomous. So I'll just show a couple of examples here. So one of these sort of tricky problems that needs to be solved is dealing with the lenses changing over time, and especially changing with temperature. So you can see here at different temperatures, the lens has different calibration properties. So this is something that we've characterized in the lab, and we actually estimate dynamically online as it's flying to compensate for it actively. Another example is dirty cameras. So we have a system devoted to detecting smudges or other defects with the lens and being able to behave appropriately. So the initial behavior here is that the drone will be more conservative, moving in that direction, and if it gets too bad, it'll notify the user and ask them to clear the lens. So these are just a couple of examples. So what are we doing with this really powerful technology foundation and this consumer product? So a huge part of our vision has always been using this as a platform and making it useful for enterprise applications as well as public safety and government use cases. It's always just been a question of when, and the products and technology have matured to the point now where we know we're there from a product and a tech standpoint, and the enterprise markets are also maturing, where people are actually starting to use drones and get some value from them. So we're extremely excited now to be taking this technology into these enterprise applications. And one of our first major use cases is residential roof inspection. And this is one of the ones that people have been talking about for years. It's kind of obvious that it's better to send a drone to inspect a roof than have a person have to climb up on a ladder, but nobody's really been able to make it scale. And the missing ingredient is autonomy. So this is something that we're really excited to be working on. And we've extended our autonomy system for these kinds of inspection applications. So I have a couple of examples here for this general category of 3D scanning. So we've done some specific things in order for the drone to be able to relocalize and have a persistent map as it's flying around a structure. We create a much higher resolution 3D model, which it can use adaptively to make sure that it gets complete coverage. And then we iteratively refine against that to make sure that we get all the vantage points that we need to have complete coverage. So we're very excited to be working with EagleView on this, and I'll show a video of this system in action. So the workflow is very streamlined. You basically take the drone to the house. You control the whole thing from an iPad from one of our controllers. You tell it to take off, the drone goes up in the air, and then you have a nice user interface to specify which house you want to inspect and the extent of the property. So once you give the drone the basic bounds, it will fly in and build up this high resolution 3D model. So that's what it's doing now, and you can see it creating that model in real time. So once it's got that model, it can recognize individual roof facets and use that knowledge of individual roof facets to plan a path at very close range where it's capturing ultra high resolution imagery of the entire roof. So this is the kind of task that even the world's best drone pilots would be hard pressed to fly with this kind of accuracy and repeatability, right? So this is an area where we're really deploying autonomy to do something that's at the limit of human capability. And of course, none of this makes sense unless it can also avoid obstacles. And those two things together are really powerful. So we think this is a big step forward for the drone industry and also for the insurance industry. It's something that we're very excited to be a part of in partnership with EagleView. And one of the analogies that we use to think about this space, which we've seen in other spaces as well, is the transition from kind of hardware-centric to software-centric devices. So we saw this happen with phones, where we went from flip phones, where every feature that phone needed to have was built into the hardware, to smartphones, where the device itself is essentially a canvas for software. And there's a huge range of applications built on software on top of it. And any software application that you can imagine, you can build on top of the platform and then becomes useful for people out in the real world to take advantage of. The bottom line with autonomy is that it makes existing use cases easier and better, and it opens up entirely new ones. And this is something that we see today in the insurance market using drones for automated roof inspection. It's something that we're very excited to be a part of. We're excited to be working with EagleView. And we're most excited to have this technology out in the real world, in customers' hands, providing value, keeping people safer, and allowing folks to do their jobs better and faster.
Good morning. It's about 7 o'clock here in California, and I came out to this park early so there'd be no one around so I can fly this drone. The question I have, we know from Adam how unbelievably great this thing can be in the hands of someone who really knows what they're doing. You've seen the video footage. The question is whether or not someone who doesn't know what they're doing can do. So we thought, let's try an idiot. I'm the test pilot. So a little bit of background. I have a drone that I bought about 5 years ago, and I flew it a lot. It's a manual drone, so it didn't have any of this autonomous features. So I'm not a novice when it comes to flying drones, but it's been a while, and I've had no experience with autonomous flight. So the folks at EagleView sent me the Skydio, and I looked at a bunch of YouTube videos, and I have spent a total of 20 minutes flying it around in 2 different sessions. So that's the extent of my experience. 5 years ago, I flew drones kind of as a hobby, fun thing, and then 20 minutes of flight time and a couple of YouTube videos. So what I'm going to do today is I'm going to walk you around this park here, which has a bunch of trees and shelters and things in it to test it. And one of the reasons I picked the park, in addition to the fact that the Ritz-Carlton's on the hill, is also that I was here a couple of years ago and there was a drone in a tree that someone was trying to get down with a stick. So this is a good place to test. So here we go. Let's give it a try and see what I can manage. Flying in 3, 2, 1. And up it goes. So here we go. We're flying through the trees. And so far, so good. I'm flying it backwards. And I'm going to come through here. See how this works. Can it follow me through these trees? It's going to be tricky. And there it is. Wow. Now I'm in another tree. It still got me. So I'm now I'm going under a shelter. I don't really know what's going to happen. So it's got me. Now I've lost theirs. Visual contact got lost for a minute, and now it's trying to figure out what to do. And we're talking about a very, very tight space. There's a lamp. It's lost me. It's lost me. There it is. It's got me. I guess when I say it lost me, I don't think it did. I think it's got me. And there, my friends. is the Pacific Ocean that we did not get to come to because the Ritz-Carlton is not open for that kind of business. I'm going to walk through these trees one more time just to see how that works out. Ooh, and there's a really tight spot I'm going to try and walk through. So it doesn't know where I'm going, it's backing up, and as a consequence it can't necessarily, wow, wait till you see when it comes out the other side how tight that is. That's pretty amazing. So one of the cool things about the drone is if you get it right over its case, just like this, and you tell it to land, it will land, it sees the case, comes down to it, and with any luck, will land right on the case and shut down. That's a pretty good trick. Okay, now that we've proven an idiot can fly this, because I did, we need to figure out what are we doing with this much more sophisticated autonomous flight? What is it that's going to help the insurance industry? How do we get it into the workflow? So the next step, we'll turn to Bill Banta from EagleView, who's going to help us understand how to take this technology and turn it into useful information. Thanks for coming out to the park with me today.
Thanks, Adam, for sharing the state of the art on drones and Skydio, and thank you, Brian, for having us here today. I wanted to take a few minutes and share how some of the exciting technologies like Skydio are generating really exciting data sets for virtual inspections and how that data can be consumed in a virtual claim workflow. Drone inspections are extremely difficult, and one of the reasons that they've been challenging for so many years is they've all been flown by hand. And even the most professional pilot has a hard time getting the level of image quality and getting a comprehensive inspection. So this is a snapshot of the interface from an EagleView on-site drone pilot app. And you can see the level of complexity there that the pilot has to manage to pull off a successful flight. And it's just too much. And the new technologies like Skydio that are bringing automation to bear allow us to provide much more comprehensive and much more detailed inspections like we'll talk about later. So we've spent a lot of time thinking about what are the right specs, what are the right metrics for image quality that allow an adjuster to make a really high quality decision that they can be confident in with drone imagery. And so one of the metrics that we've fallen on in working with several of our customers is a metric called GSD, or geospatial distance. And that's the amount of area on the ground or on the roof that a given pixel captures from the image sensor. And so just for some perspective, a satellite captures 1 meter GSD. So a single pixel on a satellite captures 1 square meter of earth on the ground. A manned aircraft is capturing 5 centimeter, or about 3-inch GSD on a consistent basis, which is great. It provides a really high level of image quality, but it's not enough to really see small or light hail damage on a roof. And so in working with our customers, we kind of found the sweet spot is actually less than 1 millimeter of GSD per pixel. And that's a very, very high tolerance, very, very high spec for any manually flown drone to achieve. And it requires a level of integration and automation to be able to capture that detail over the entire roof. So this is a snapshot of a native 12 megapixel image captured from a Skydio drone. And on the surface, it looks very good, but you can't really see anything here. So we threw a couple coins up on that roof to give you an idea of how powerful sub-millimeter GSD actually is. And if we zoom in, you can actually see the individual faces on those coins. And that, we believe, is the level of detail required to help adjusters make confident decisions with drone imagery in the real world. So we talked about image quality. Why is automation important? Well, first of all, automation is what allows the drone to fly that close to the roof and capture that consistent GSD for every single facet. Secondly, when you're trying to fly that close to the roof, you need a really complete data set to make a correct decision on that roof. And so automation allows us to ensure that we've captured all the surface area of that roof at the right GSD to give the adjuster what they need to make the right claim decision. So here's an overlay of a single roof from a job that we've flown in the real world, and that green overlay is the is the amount of area that was captured at that sub millimeter per pixel GSD on that specific job. But when you get into automation, in many cases we're looking at state of the art and new technologies, and so it's important to test those technologies and make sure that you're not stepping into a program where you're really working on a prototype and working through the kinks and bugs of a new software platform. So one of the things that's important to consider is, what does your test plan look like? How many jobs are you going to do before you feel confident that the solution that your vendor is bringing forward has the right level of performance to meet your needs as a business? And so we think it's important to do thousands of test flights in the real world. And that may sound like a lot, but when we talk about automation and we talk about AI, it performs very well most of the time. And it's the corner cases that you want to find out during your test plan, so that you don't actually see those in the real world when you're putting it in front of a customer. And so we think a 99% plus metric in terms of success rate is the minimum threshold across thousands of jobs before it's ready to move to the real world. And when you see those anomalies, when you see those deviations from the expected performance in the real world, it's critical to really understand what the root cause is. In some cases, it's the software that can be fixed, and the system can be programmed to do the right behavior next time around. But in some cases, there are human factors that cause the drone to behave in unexpected ways, even when it's operating in a quote-unquote automated flight plan. So it's really important to work through a large number of test cases in highly variable conditions to ensure that you as a customer are confident that the system is going to perform the way you expect it to when it comes time to put this in front of your policyholder. The final thing that we've learned as part of our test flight program has been the importance of understanding battery life and how that impacts the overall inspection. So is the system able to consistently fly a typical house on a single battery? If yes, that's great. If it's time to go fly a large house and there's multiple batteries required for that drone to complete the inspection, how does the system perform? And some of the things that we've seen in the real world are, when you power down the drone by taking off the battery and putting on a fresh one, the GPS can become miscalibrated, or the accelerometer can become miscalibrated, or the drone alignment and calibration back to the roof can be off. And while these seem like trivial things, being off by a foot or 2 or 3 feet, which for many sensors is a standard level of error when you're restarting it, it can cause the system to behave in unexpected ways, and can force a reinspection of that property, which is something that we're absolutely trying to avoid. So just things to keep in mind when you're evaluating a test program for drones in the wild. So we talked about the GSD required. We talked about providing really comprehensive inspections by using automation that scan the whole roof. And what you get when you fly close to the roof and when you take lots of pictures to scan the whole roof is you end up with a big data problem. And so for a typical roof in the US, we're seeing 3 to 4 billion pixels of imagery just come back for the roof. And to streamline the workflow for the adjuster, we've got to apply some tools like machine learning to make it easier for them to consume that extremely large amount of data. So we have embarked on a very deliberate effort to bring ML into drone and virtual inspection tools. And one of the things to keep in mind is there's a lot of people making big claims about their ability to identify hail and wind damage from drone imagery, but we've taken a hard line and said we want certified adjusters to be the people that are training these algorithms. And there's a lot of different ways to do it. It's very low cost to outsource the image tagging to people in China or to people in India, but we felt that to have a really high degree of confidence in the system that we were bringing to the market, it needed to be trained by adjusters here in the US, here in Canada, to give the best quality output for the customers. The other thing is you need a large variety of images in that library to make sure the algorithm performs consistently across a wide variety of roofs. And this means testing the system in different weather conditions. Is it cloudy? Is it sunny? Testing the system across different makes and models of shingles, different colors of shingles. All of these things can have very big impacts on the performance of the system in the real world, and are all things that you as a customer should consider and know before embarking with your own drone program internally. And then finally, is whatever machine learning tool you are using, is it an actively learning system? So is it continuing to improve and get better as more skilled adjusters review images and help the system basically learn over time as it sees more and more images and gets more and more feedback from the real world? So now that we've talked a little bit about machine learning and how we make a large amount of data consumable, let's talk about what the interface looks like for the adjuster. So at the top level, we give the adjuster just a very clean, highly detailed overview of the home. We help them orient themselves to the property and really understand the contextual information for that claim. Next, we use our machine learning to overlay what we call a heat map over that roof. And so we take a facet by facet approach. We use the machine learning to really measure the amount of damage on each facet. And because hail and wind are many times directional, only certain portions of that roof are likely to be the most damaged. And so if we take facet O, for example, and we want to zoom in there, we can overlay a test square on that facet. And this is just another way of taking a tool that adjusters are very comfortable using in the field. We take a standard 10 by 10 test square, we overlay it on the roof, we put it in the location where the machine thinks there's the most damage, and we'll let the adjuster zoom in and go to work. Now, if they want to move the test square around, absolutely they have the flexibility to do that. But when they get that test square, you see that window pop up in the top right, and that's what we call the anomaly detection window. And so this provides a really zoomed in view of each individual anomaly and allows the adjuster to confirm or reject that anomaly. So at the end of the day, the skilled adjuster is the expert making the decision, and all the system is doing is help streamline the workflow and help guide them to the areas where they need to make that decision. We've also included the ground shots from all around the property. So whoever is flying the drone has a configurable shot list, and they have to capture all of the required images before they're able to complete that job, ensuring there's a complete image package for the adjuster. And the adjuster also has the ability to add notes or annotate that image and include any of those images in their final adjuster's package. So when thinking about the ROI for drone packages, a couple things to consider. How many re-inspections are you getting and why? Is it because you're not getting the right level of image quality? Is it because you're not getting a comprehensive inspection? Is it because a pilot went out to fly and it turned out the airspace was restricted? These are all data points that you, as the customer, want to understand before it's time to move that service into the real world. Adjuster efficiency. How much improvement are you getting as an adjuster on a claim-by-claim basis in terms of time saved by being able to go through the entire workflow in a highly efficient manner and be confident in the quality of the decision that you're making at the end of the day? In terms of regulatory compliance, do your drone vendors have the right level of regulatory oversight to ensure that each individual pilot is the person that's licensed to do that job? When we talk about new levels of automation, it's important to really ensure that the person operating the drone is the licensed pilot, because there's always a chance when it becomes fully automated, somebody hands it to their brother or their cousin, they go out and just have to press a button on the ground and they try and fly that job. So we've added things like biometrics into our drone pilot app to ensure a very high degree of compliance from a regulatory standpoint. And then finally, the financial returns. Are you seeing the cost savings from an adjuster efficiency standpoint, and are you seeing cost savings in terms of on-the-ground inspection costs, particularly for steep and high properties, to really justify the transition and the training within your workforce? So, wrapping up, it's really exciting to see some of these new technologies mature around data collection and workflow validation and machine learning, and making it much easier for adjusters to evaluate the enormous amounts of data that are being produced by modern drone platforms. As we look to the future, we think it's really exciting to take this technology away from just a single property and think about doing wider areas inspection. So if you think about having a drone and being able to inspect an entire neighborhood in a CAT event, we could fly the drone around a neighborhood, get that higher level of inspection, and in many cases, as you see here at the bottom of the slide, provide the level of imagery that can give you as the carrier some interesting cues as to whether or not a home has been catastrophically damaged, or whether or not you want to trigger a more detailed inspection of that roof. And when we talk about larger scale inspections, this gives insurance carriers the ability to look at a wide area and do a very, very effective triage and really understand which properties need the most attention earliest in a cat event. So I hope I shared something new with you today. I hope you had an opportunity to learn something. And like I said, we're really excited about seeing some of these technologies mature and come to market in 2021. If you have any questions, feel free to email me, and thank you.
Thank you very much, Bill, and thank you, Adam, for bringing us so much information about a brand new way for drones to fly. When we first started examining drones at our conference, it was in 2014, and interestingly enough, it was someone from EagleView who was showing off some experimental flights, autonomous flights that were happening, building 3D models, and it was sort of the front edge of it. I was so inspired. I actually went out and I bought my own, this is a 2014 DJI Phantom 2 Pro Vision something or other, and I spent hours trying to learn how to fly this thing so I could get it to go in a smooth way. And then, as you saw in that video I showed you earlier, this is the new Skydio. It's a whole different level of technology, and we've come a really long way, which is exciting because it's always great when technology goes from rough idea to actual reality. And so we're right now at a stage where we're reaching actual reality, which is kind of crazy. And I was hoping, Bill, having heard you walk us through the process, I was hoping I could get you to go a little further back and just tell us some of the history of EagleView and the drone process and sort of the journey that you've gone on to get to where you are now.
Sure. Thanks, Brian. So as you mentioned, EagleView's experimentation with drones goes all the way back to 2014. It was probably 2016 when we started to do our first jobs in the field. And then over the course of 2017, 2018, 2019, started to ramp that product up. And 2019 is probably when we made the most significant changes to the product since launch. We added a completely new pilot interface since we had learned about some of the challenges that pilots were experiencing in the field. And then we also started to add in our first iteration of ML-powered anomaly detection. So we ran that through 2019 and continued to see a lot of the problems that are inherent in any sort of manually driven flight. And that's when we became very close with our friends at Skydio.
And so when did that partnership begin? Was that 2019?
Yeah, so we started that partnership discussion with Skydio in 2019, and we've been working closely with them ever since.
And then that was their first commercial drone, right? It was late 2019 was really when they first started to sell them commercially, to consumers, and where I could buy it, for example.
Yeah, so Skydio had a first iteration of their drone called the R1, which was really focused on consumer applications and really demonstrated a lot of the cool automation, object tracking, and obstacle avoidance technologies. And since then, that technology has just continued to improve dramatically. And then at the end of 2019, they launched the Skydio R2, which is what we're using for EagleView Assess.
And is EagleView Assess in the market now? Do you have customers that sort of give me a sense of where you are in that process?
Yeah, so EagleView Assess is in beta right now. We've got a couple customers where we're doing jobs primarily in the Dallas-Fort Worth area, and we're looking to expand that geographic coverage dramatically for the start of storm season in 2021.
And do you think, we had talked about this earlier, no one knows for sure, but do you think this is something that claims adjusters, insurance company claims adjusters are going to wind up managing? I was going to say fly, but theoretically they're not. Or do you think it's going to be third parties or a mixture of both?
I mean, our goal is to make it easy for customers to have whoever they want fly the drone, whether that's a third-party pilot, whether that's an internal employee or a staff adjuster, or whether that's an IA. And so we built the technology with that in mind. And we're going to be going to market with third-party pilot networks, but we're actively working on different ways to train third-party pilots, IAs, staff adjusters, et cetera, to make it easy for them to get the right level of FAA certifications to operate the drone safely and legally.
Yeah, because that's still part of the game. I mean, there probably isn't a time in the near term where you aren't going to need to be a licensed pilot to bring this out to the driveway and push fly.
Correct. Not in the near term.
Yeah. Well, and it's not that difficult. I mean, I have my certification, and it's not that hard.
It's not that.
It's not like it's not like getting a motorcycle license or something, or
right.
Or a private aircraft. So it should be possible. One of the things I was thinking about as you were talking and you were showing the image quality of those coins on the roof, it occurred to me that probably any drone could take that picture. The question isn't so much can you get those coins as can you get every inch of the roof at that quality. And I guess that was the challenge to some of your earlier projects.
Yeah, I mean, the challenge with on-site was not can we generate great image quality. The challenge with on-site was can we generate great image quality over the entire roof. And that's where partnering with Skydio really allowed us to take a huge step forward in terms of delivering that level of image quality across hundreds of images for a given property. And we do that with the Skydio automation that allows that drone to very consistently fly just about 3 feet from the roof. And that, gives that level of clarity and detail that both the ML and the adjuster need to be confident in the decision.
So when I was flying the Skydio, and as I showed you guys earlier, there's a height limiter on it that keeps it, I think it's 15 feet in the air for safety reasons. And you can turn it off, but you get these warning notices like, are you really sure you want to turn this off? And when I walked through those trees, I did have it off. And so it is possible to fly low, but it's hard. And I think that's the other factor, is it's not just consistent on the roof and flying tighter, it's that it doesn't crash. I mean, that DJI has been in a lot of bushes. It hit a car, didn't leave any dings, so I didn't leave any notes. But I've flown the Skydio, again, without a whole lot of skill. And I have not, knock on wood, I haven't managed to crash it yet. So since it's not mine, I'm going to try and keep that up. But that seems an important part. I want to talk about workflow a little bit. If you could you walk me through, so I'm an insurance company and I want to get a roof examined through a drone flight. Can you just sort of walk me through the workflow? How does that start, and how does it work going forward?
Sure. So we've got a really easy web interface so that adjusters or claims handlers can order and assess inspection. From there, depending on the carrier workflow, either that claim handler can schedule the inspection, or we have a self-service scheduling tool that goes out to the homeowner and allows them to schedule via very, very clean web app. So if they want to do it on their mobile phone or if they want to do it on their computer, it makes it easy for them to select the times that are most convenient for them and lock in that inspection. From there...
if I can interrupt you, so the homeowner needs to be home for this?
The homeowner does not need to be home. They have the option to be home. And so they're allowed to schedule that inspection at their discretion. So it can be when they're at work, when they're taking the kids to school. It doesn't matter at all. Okay,
great. I'm sorry, go ahead.
So from there, there's a series of notifications that get sent to the homeowner. So there's a reminder that the inspector's on the way. There's a confirmation once the inspector has arrived at the property. All this is to make it very easy for the homeowner to be very aware of what's taking place with their claim, and to also provide them the opportunity to keep socially distanced. So in this time of COVID, people don't want people knocking on their door and dealing with another individual face to face. So we've tried to take the appropriate steps to automate that and make it all happen through very standard digital notifications. So once the pilot has notified the homeowner that they're there, they work through their inspection. So they've got a shot list that they capture on the ground, and then they launch the Skydio drone for the Skydio drone to complete its inspection of the roof. And then once they've completed that job, another notification goes to the homeowner that the inspector is done and they'll be leaving. That data is then uploaded to the cloud. The file sizes are generally 3 to 4 gigabytes for the standard house, so it takes a few hours to upload that data. And then it's processed in our cloud, and then it's available for the adjuster to review the next morning. So all in, depending on the upload time, inspections can be ready in a few hours for adjuster review.
But it's if it takes a couple hours to upload one, if I'm out flying a couple of houses, say I get 4 in a day, that's going to run all night.
Sure, and our promise to the carrier is to have those inspection packages available for review the morning after the inspection.
Yeah, that makes a lot of sense. Yeah, because and this goes to one of the truisms that and you talked about it, managing lots of data, and I kind of got in trouble here 10, 15 years ago as I was looking at some things, some technological advances, and I'm like, that's just too much data. The transmission time is too long, the cost is too high, and it's always dumb to fall into that trap because transmission always gets faster, the cost always falls, the files always compress, storage becomes much less of a problem. Doesn't mean it's not difficult in these days when you have to take all night to load it, or all night to like charge an electric car.
Right.
But as you're looking forward and you're trying to plan, you can assume tomorrow's better than today.
Absolutely.
For sure.
And, as we look to the future, one of the big technologies that we see unlocking much higher data rates is 5G. So in a 5G future, we see a world where the pilot goes and flies a job and that data is ready for the inspector to review same day. We're not quite there yet. 5G networks aren't as pervasive as we'd like them to be, but that's definitely something on our roadmap.
But if say it's a year from now, and there is a 5G node somewhere, and you can find it on your phone, and you're this adjuster, you can go there and in the span of 45 minutes upload a file that could take all night.
Yep.
That's worth doing, and you can see that bridge. And that's part of what I was pointing out. This technology, it moves so fast, you can't let today's barriers extrapolate out into the future because they just go away.
Absolutely.
They just do. So once it's in your system, what happens next?
So once the assess data package has been uploaded, it's viewable in the assess adjuster UI. And that allows the adjuster to go in, see an overview of the property, and see how the machine learning damage detection algorithms have evaluated the extent of the damage on each facet of the roof. So there's a heat map, which we talked about earlier, to help guide the adjuster through the claim workflow. There's a test square on each facet to further streamline that workflow. And then once the adjuster has made the decision that they need to make for each of the individual facets or for the roof as a whole, a report is generated, a PDF file, and that can be attached to the claim file. And then in the background, we continue to store all of the underlying image data so that if the carrier ever needs access to that in the future, it will be available.
So when I'm, in terms of how I operate, is it similar to the way I get a traditional EagleView report in a claims file?
It's similar to the way an EagleView report's delivered today. We're working with the large, estimatics platforms to drive a deeper integration. We're not going to have that out of the gate. So right now we have a nice clean PDF that provides all the data required to settle that claim. But in the future, one of the things we're looking to do is provide that deeper level of integration to further improve that adjuster workflow.
So in the early going, if I'm an adjuster, I get the PDF, I see the anomaly report. Will I have a platform where I can go and look at the pictures and roam around more on my own?
Yeah, absolutely. The PDFs, are just basically a time-stamped version of what that adjuster, determined the outcome for that claim to be.
Okay.
If somebody wants to go back and review it, or if somebody wants to go back and change that decision, they absolutely have the ability to do so. A new PDF is generated, and they can move forward with the claim from there.
Bill and I didn't talk about this, so we'll see how he goes. It feels like a 12 to 24 month rollout from here.
Yeah, I think that's about right. When we talk about broad scale coverage in the US and Canada, we think that's going to take most of 2021. We're going to obviously work with our customers to understand the highest priority areas, but our goal is to have 25 to 50 of the top metros covered by the end of summer 21, and then further expand our geographic coverage from there.
Well, and then, there's a matter of getting enough of these things made.
Yep.
Because, the demand is high. I mean, there's a few others. The Mavic is a really nice drone, and they've sold more than 1 million of those. I mean, this is going to take some time.
It's going to take a little bit of time. We don't view hardware availability or pilot availability as the main bottlenecks. We think we just need to get adjusters on board, comfortable with the new workflow, and that's going to take some time. It's a new workflow. It exposes the data in a new way that people haven't seen before, and frankly, in a more comprehensive way. And there's some tools to help increase the throughput of the adjuster, increase their efficiency. And so once we start to see adjusters get over that hump, that's when we believe there will be much stronger adoption. So, in the beta programs we've done today, it takes somewhere between 4 and 8 claims before an adjuster really ramps up from a productivity standpoint. And so depending on how many assessed claims an adjuster is exposed to out of the gate, that's going to impact how quickly they ramp up on the new product and how much pilot capacity we're going to need.
What I like about this idea is it's in the continuum from 14. I mean, the ideas we were talking about 6-7 years ago, sort of the pie in the sky. Wouldn't it be cool if you could just throw the drone in the sky and it'd fly around the house? That's kind of what we're doing, right? I mean, it's not a brand new change. And the nice thing is that this is a step, right? We had the first drones. They were better than getting on a roof. They weren't as good as they could be. And we're just going to keep seeing this progress as we talked about data transmission and cost and everything, and storage costs all falls, and will continue to do so. The same is true of these things. They'll just get better, and they'll fly in higher winds and lower light, in more challenging environments. There were a few times I freaked this thing out. I was walking around and it was like, okay, I'm not interested in going there.
Yeah.
But every day they'll just get smarter, and there'll be competition. Lots of people will be doing it, so it'll be great. When you look, take me out 3-4 years. Where do you think this goes?
I think there's kind of 2 ways that we're going to see a lot of significant technological improvement over the next 3 to 4 years. One is in the underlying quality of the damage detection algorithms. Talked a little bit about that earlier, but EagleView is adding thousands and thousands of data points each week from certified adjusters, and that's not the most cost-effective way of generating a high-quality data set, but it's something that we believe is important to have as the foundation for our damage detection software. So we think that will continue to improve significantly and will allow adjusters to be even more efficient as they work through an inspection package. And then we also think we're going to get a larger area of coverage with a given drone. So today there's some rules around BV loss, beyond visual line of sight operations for drones. EagleView and Skydio are partnering to influence some of that regulatory environment and make wide area inspections more accessible for carriers, which will just make inspections that much more efficient, especially in a CAT event where one pilot could launch a drone from a single location and inspect dozens of homes.
Yeah, that is ultimately, it's a factor of battery life as well. As you mentioned, if you got 20 minutes, you can't do the neighborhood.
Right.
There's someday there'll be fixed once we kind of process it in our heads. There'll be fixed wing drones covering neighborhoods, but given the whole predator thing, everyone's got to, it's going to take us a while to let that marinate in our heads before we're cool with that.
I think that's true.
But certainly there's a lot of gain to be had, in the quadcopter. I want to take you back to something you talked about, and that is training the AI. The first thing that comes to my mind is that every single passing day, every time one of these things goes in the air, the artificial intelligence will get smarter.
Yes.
And a data point collected 5 years ago and a data point collected today will only differ in, say, image quality. And so it really will be just building. And so I have to think, I hadn't really thought about that. Of course, I get all jazzed up about the flying, but the volume of imagery will just accelerate the AI quality off the charts. 5 years from now, the ability to identify exactly what that is. Is that hail? Is that just a shadow? It'll probably be astounding.
Yeah, I mean, we're already starting to see big leaps forward in the quality of the ML. We actually never specifically trained our damage detection algorithms to find cracked shingles, but after tens of thousands of jobs, it actually started to do that all by itself. And so if it's starting to see things like that, which are obvious damage, as it gets a more robust and larger data set, it will become better and better at identifying the types of damage that, experts in the field are really the only people that can identify today.
Yeah. Well, and what's nice is I have to think, right now the cameras can capture image quality. We don't need better cameras. We need better autonomous flight, which will only happen with more drones in the air, more companies competing, more efforts, more cameras. I think one of the things, I'm not sure Adam got to it in as much detail, but this drone had one camera. Oop, there's some paper there. This drone has 3 on the bottom, 3 on the top, or I guess I gave it to you backwards, 3 on the bottom, 3 on the top, and of course this one here. So you could see a day with more, one in the back. So it's definitely going to get better. That's really the magic, is just getting that better. So, well, Bill, I can't thank you enough. I'm really excited for this. I'm always in love with beta projects. So whenever I can do something at the conference that's just about ready for prime time, that's like my favorite thing. So I really thank you for sharing your time, for introducing me to the Skydio folks, and I wish you the best of luck with this going forward.
Thanks, Brian. Really appreciate it.
Okay, thanks.
All
See
right.
you all later.
Bye.